Okay, good morning, everyone. Let me start off. If anyone has any questions, be happy to go over anything. Anything from the homework? No? Okay. All right. So last time then we were talking about sketching lines, right? And we were looking at the intercept method. So let me get back to where we had discussed that. Here we go. So remember, if I give you a linear equation, basically you need to draw me the line, right? And there are two methods to do this. There's the intercept method, and then there's the slope intercept method. Last time, all we talked about was the intercept method, right? So let's finish that up. There's a few things I want to do with that, and then we'll go ahead and move on to the slope intercept method. And then we'll see if we get past that, then we'll see in terms of our schedule whether or not we want to move into the next part, which would be parallel and perpendicular lines. Okay, so there's a few cases that we conveniently avoided last time, specifically problems that have fractions in them. So let's take a look at an example of a linear equation with two variables where we have fractions, and then how we deal with that. So let's go ahead and sketch. This is an example here. Let's sketch this line. 1/2 x minus 2/3 y equals 4. Okay, so we're going to do the slope intercept method on this. Or sorry, not slope intercept method. We're going to do the intercept method. And so our goal is to just get 2 points, right? That was the whole idea. We just try and get 2 points. So the first point we're going to get is by finding the X-intercept. And who can tell me what we do to find the X-intercept?
Set the y equal to 0.
Set y equal to 0, that's it. So we just take the equation, 1/2 x minus 2/3. We replace the y with 0 and then set that equal to 4. And then we just solve this for x. So our goal is to try and get this x by itself. So we realize that 2/3 times 0, that just goes away completely. And so all we're left with is 1/2 x equals 4. So this is a linear equation with one variable now, but we have some fractions. Well, you kind of can look at this two different ways. With this 1/2 in front of the x, you can divide both sides by 1/2, or you can multiply both sides by 2. Those are equivalent operations. So let me just ask you, anyone who wants to respond to this, how many of you, or who would divide by 1/2 here? Yeah, I see you raising your hand. So let's do that. Let's divide by 1/2. Right? If we divide both sides by 1/2, we have to take this, divide it by 1/2, and then we have to take the 4 and divide it by 1/2 also. Now on the left-hand side, the halves just go away and you just have the x. But on the right-hand side, this is where things can be a little bit confusing. That's why I want to make sure I clarify this. We're taking 4 and we're dividing it by 1/2. That's what's happening on the right-hand side. So this is where you have to go back and remember how we do division and fractions. You have to rewrite the 4, excuse me. You have to rewrite the 4 as a 4/1. And this is where you do the, keep dot flip thing. So we're going to keep the 4 as a 4. We're going to change division into multiplication. We're going to flip the second fraction over. So it becomes 2/1. And then we multiply straight across. And when we multiply across, we get 8 over 1, which is just 8. So I did this kind of on the side just to make sure we understood what we were doing here. But the right-hand side is going to turn into 8.
Sir, I have a question.
Yes.
Would you be able to just multiply both sides by the denominator and then divide? So you would multiply like 1/2 by 2 and 4 by 2, and then you divide by 1.
Yeah, so that's the other way. So when I had the 1/2 x equals 4, and I asked, how many of you would divide by a half? A few of you said you would divide by a half. So that's the way I showed you. The other way to do it would be to take this and multiply both sides by 2. You could really just multiply both sides by 2 over 1. And then look at the right-hand side as being 4 over 1. And so the 2's cancel, the 1's cancel, you get the x. And on the right-hand side, you still get the 8. So that's the other way. I think that's what you were kind of alluding to. You said multiply both sides by 2 and divide by 1. That would give you the same thing. So it's really up to you how you want to do that, whichever way makes more sense to you, but you should get the same result either way. Okay, so now we have the X-intercept. Now we go get the Y-intercept, right? So for the Y-intercept, we're going to replace x with 0 this time. So we replace the x with 0. All right, that first part, the 1/2 times 0 goes away. So all we're left with is the -2/3 y equals 4. And now again, you could either divide both sides by -2/3, or you can multiply both sides by the reciprocal, which would be -3 over 2. I'm going to do the division again, just because. Divide this side by -2/3, divide this side by -2/3. It goes away on the left. I'm just left with the y. And then on the right-hand side, I'm going to do that over here. I'm doing 4 divided by -2/3, which is the same as 4 over 1. And this is where I'll do the keep dot flip. And then I multiply straight across. So I get 12 over -2. Sorry, I was already putting the answer there. So I'm multiplying straight across. 3 times 4 is 12. 1 times -2 is -2. And this should give us -6. So we get -6 here. And that's our Y-intercept. And that's all we need. If we want to graph a line, we just needed 2 points. So now I'm ready to go ahead and graph this. I think I'm going to have enough space here. So I want my X-intercept was 8. So on my graph, I'm going to go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put a dot. And then on my y-axis, I'm going to go to -6. So 1, 2, 3, 4, 5, 6. There's -6. I put a dot. And then I draw as straight a line as possible through those 2 points. There we go. So just so that we understand why the graph is useful, I'm going to rewrite the original problem over here. And let me just ask you real quick, is it possible that let's say -4, +6 could be a solution to this? Is it possible that this is an answer? So think about where this point is. It has a negative x coordinate and a positive y coordinate. A negative x coordinate means that you're over here somewhere, and a positive y coordinate means you're up here somewhere, right? So we're talking about a point that lives over here. There's no way that that could be an answer. And that's why the graph is kind of useful. Just by looking at it, we can eliminate certain possible solutions, right? Another solution here, we could ask ourselves, how about 0, 0? Well, we don't even have to plug that in because 0, 0 is this point right here, the origin. And we know that that point is not on the line. So having the line actually does give us quite a bit of information about what is possible to be a solution and what's not possible. And I was sitting here earlier today and I was thinking about something, and I thought I would share it with you all. You know, as you sit here and we go through these, you know, graphing lines and doing all this little algebra here, you know, you can't help as a student wonder, you know, why in the world you would ever need this in your life. We've had this conversation a little bit before, but it's hard to see how this is practical in life. So here's kind of just something to keep in mind. I'm assuming everyone in here has used a hammer before, right? Like, you know how to use a hammer. You get a hammer, you get a nail, you know what to do, right? If I give you a screwdriver, you know how to use a screwdriver. If I give you a hand saw to cut a piece of wood, you know how a saw works. Pretty much all of algebra, all of pre-calculus, all those courses that students take is just teaching students how to use tools. So it's like being able to graph a line is like being able to use a hammer. And being able to graph a parabola, which we'll do later, is like being able to use a saw. You actually don't start building anything with math until you get into like the calculus sequence, which a lot of you aren't going to do. So I know it's difficult right now, because right now you're like, why is this useful? Well, it's like saying, what's the use of a hammer? Like, we don't ever get to build a house, okay? Like, we're never going to build a house, but you'll know how to use a hammer. So it's trying to see the forest through the trees. Like right now we're kind of focused on one thing. We don't know why we need it, but you have to trust that it's useful at some point later on, for people who do engineering and stuff. All right, any questions on this one? Okay, let's move on to another example. The next example I want to do is a unique scenario. All right, so here's the unique scenario. Here's the equation. I want us to sketch x equals -3. All right, so the first thing that should come to your mind right now is that this is an equation, but it doesn't have two variables, right? It has an x, but it doesn't have a y. And everything we've done up to this point has been x's and y's, and then we go find the x-intercept by setting y to 0, and you find the y-intercept by setting x to 0. So this we can't do that with, right? Because there's no y to set equal to 0. So this is not going to fall into the same category. So this is a special case, all right? This is a special case. And I'd like for you to consider what this line looks like. It is a line. This is still a line, but let's try and understand why it's going to be the line it is. Okay, so I'm going to draw this graph. Now remember, the line that we draw represents all of the answers, right? All the ordered pairs that make this equation true. That's what we started with last class. So let me ask you, is this point a solution? 2, 5. Okay, is that a solution to that equation right here? Well, the equation says that x has to be -3, right? So all you have to do is look at the x coordinate right there, the x. Is it -3? No, right? So that's obviously not a solution, right? What I would need is for the x to be -3. So how about this one? Would -3, 2 work? Well, is the x -3? Yeah, okay, so that would work. Is that the only answer? Could I come up with another ordered pair that also has a -3 as the x, but maybe a different y, like 0? Well, is the x -3? Yes, right? So that would work. In fact, any point that you come up with, as long as this x is -3, you could go, you know, forever and just keep picking points. So the y doesn't matter. So let's take a look at what those points look like if we started to plot them. So if I start graphing these points, the first point, -3, 2, would be to the left 3 and up 2. Okay, so that's my first point. -3, 0 would be to the left 3 and then don't move at all. -3, 5 would be to the left 3 and then up 5. And so can you see what kind of line this is? It's all these points where the x value is -3 and the y value doesn't matter. And so what you get is a vertical line. So here's the takeaway from this. I'm going to do this on the side. If you ever see x is equal to a number, all right, then it is a vertical line through x. So for us, the x was -3, so this is a vertical line through -3. Does everyone see that? Is that pretty straightforward? Any questions? Okay, well, obviously, if we have a special case for a vertical line, then we're probably going to have a special case for a horizontal line also. So that would be the next special case. So let's take a look at that. So what if I ask you to sketch? I'll use the -3 still, but I'm going to do y equals -3 instead of x equals -3. So now we don't have an x, we have a y, we don't have an x. So if we go back and we think about what points would actually satisfy that equation, we could do the same sort of thing we just did by trying some points out. We just need to make sure that the y value is -3 this time. So I can do anything I want for x, and then the y has to be -3. Anything I want for x, the y has to be -3. Anything I want for x, the y has to be -3. And again, I could keep doing this forever. But if you just start plotting a couple of these points, you'll get a feel for what this line looks like. So if I go 0, -3, that just moves me down 3. If I go to the right 5, down 3, I can go to the left 2 and down 3. All of those points lie on a straight horizontal line. So in your homework or on a test, if you ever see x is equal to a number or y is equal to a number, you just need to kind of have that little light bulb go off in your mind and be like, oh, okay, I know this is one of those special cases. So in general on the side, if y equals a number, then we have a horizontal line through y. So you just draw a horizontal line through the actual value. Any questions? Okay. I think with that, unless you want me to do another example of the intercept method, if everyone's okay, I think I'm ready to move on to the slope-intercept method. Is that all right with everyone? Okay, let's do that then. So the slope-intercept method. And remember, I told you that on the test, you can use whichever method you want. I don't care. Okay, the slope-intercept method. So the slope-intercept method works like this. What you're going to do is you're still dealing with a linear equation in two variables. You still have x and y together with an equation. But what you're going to try and do is solve the equation for y. All right? We're going to try and get y by itself on one side of the equation. So what I'd like to do is next to these, I'm talking about the slope-intercept method on the left. On the right-hand side, what I'm going to do is give you like a specific example. So I think what I'm going to go back to the first problem we did when we started with lines. Do you remember this one? No, that wasn't it. It was this one right here. 2x plus 4y equals 8. I'm going to do that problem using the other method. 2x plus 4y equals 8. So we've already done that problem using the intercept method. Now I'd like to do it using the slope-intercept method. And then maybe at the end we'll talk about which method you liked better, okay? So for this, the first step for the slope-intercept method is to solve the equation for y. So that means I need to look at this equation. I need to get this y by itself. And to get it by itself, I have to kind of go through a process of isolating it. So I will have to first subtract 2x from both sides. Okay, so I take 2x away on both sides. When I do that, I get 4y equals 8 minus 2x. So all I did was subtracted 2x on both sides. And remember, you cannot put the 8 minus 2x together. You can't combine those because they're not like terms. They need to both have x's or both not have x's to put those together. So you just have to leave it, 8 minus 2x. And then to get y by itself, I need to get rid of the 4 out front. So I need to divide everything by 4. So that's what I'm going to do on my next step. I'm going to divide by 4, divide by 4, divide by 4. Everything gets divided by 4. So y equals 2 minus, now this one's a little tricky because 2 divided by 4, that should just, 2 goes into 2 one time, 2 goes into 4 twice. So I'm going to rewrite that as a 1/2 in front of an x. Now notice I put the, instead of writing 1x over 2, I wrote it as 1/2 times x. Those are the same, that means the same exact thing. Okay, now I wrote it this way on purpose, all right? And you'll see why in a second. Are there any questions on this? Okay, so in our steps, have we solved for y? We've solved the equation for y, right? So we've got that step done. The next thing to do is make sure it looks like this. Write it as y equals some number in front of x plus some number. So this part in green here, those are just numbers. This is some number. And then this right here is just some number. All right. So then this step is just, you have to kind of reorganize things that you have so it looks like that form. And we'll talk about why we want this in a second, but let's just do that for our problem. So we did the first step, we solved for y. Now what we want to do is rewrite it. So I'm going to rewrite this like this. Y equals, I need to put the thing with the x in front. So I'm going to put minus 1/2 x in front and then plus 2. And the reason I did a plus 2 here is because that's a positive 2. So I put plus 2 here, I move this 1/2 out in front, or 1/2 x out in front. So hopefully everyone sees now that this does look like, okay, this right here does look like y equals some number, which we're calling m, in front of x plus some number here by itself, b. Okay, so that's the next step to the slope-intercept method. Write it in that form. Now here's where I guess the new part of this comes in if you haven't seen slope-intercept before. The m, okay, the number in front of x is always what we call the slope of the line. So the slope means the pitch of the line. Okay, if you have a line, right, if you have a line, it can have different pitches to it. That number in front of x tells us about the pitch of the line, all right? And then the B is always going to be the Y-intercept. Okay, so now we know what the Y-intercept is. We've seen Y-intercepts before. It's just where our line hits the Y-axis. So the whole idea behind the slope-intercept method is this. If you can solve for Y and get it written as that form, Y equals mx plus b, then you will have the Y-intercept right in front of you. It'll be there. And then you'll also know the pitch of the line. So now let's see how we use that to graph. So once we do that, step 4, I guess, is to use, or I should do it this way. Next step would be to plot the Y-intercept. That means we're going to go on our graph and we're going to draw a dot where our Y-intercept is. So we're going to plot it. And then the last step is use the slope to find your second point. Remembering that slope equals rise over run, which we'll talk about when we do the example. All right. I think right now, if you were to look at the slope-intercept form right now, you'd probably say, I don't like this method because it's all these steps where the other method was just, you know, find the X-intercept, find the Y-intercept, and you're done. Here, it looks longer, but as we do a couple of examples, I think you'll see that this actually works pretty fast. It's not as bad as it may appear. Okay, so let's go back to the problem that we're working on over here. We solved for Y, we got it in the right form. So just so we are clear, the slope of this line is -1/2, and the Y-intercept of this line is 2. Any questions on where I got these? How about this negative? I put the negative on top, didn't I? Where originally wasn't the negative out in front of it? When you have a negative in front of a fraction, you can put the negative up on top or you can put it on the bottom. You choose, top or bottom, it's up to you. I always like to just slide it to the top. All right? So are y'all ready? We're gonna graph this line now. We have the slope and we have the Y-intercept right here. So I'm gonna go and change my paper to graph paper. I'm gonna do the graph right under here. All right, first things first, we want to plot the Y-intercept. Our Y-intercept is 2, right? It's the letter B. B is our Y-intercept. So I'm going to put a point 2 units up. It's a Y-intercept, so it has to be on the Y-axis. I'm going to put a point here. Okay? Now, from that point, this is very important. You have to start from that point. Don't go back to the beginning. Don't go back to the origin. From that point, we are going to draw our second point, and we're going to use the slope. The slope is -1/2. The number on top is always what we call the rise. And that tells you how far to move up or down. And the number on the bottom is called the run, which tells you how far to move left or right. So in this particular problem, a -1 on top means I need to rise by -1, which really means go down 1. Okay, so for us in this problem, this means I'm going to go down 1. And the 2 down here means I'm going to go to the right by 2. Right, it's right because positive is to the right and negative is to the left. Okay, so from that blue point right here, from that blue point, I want to move down 1. So I move down 1 and to the right 1, 2. And once I get to that point, I'm going to draw my second dot. And then once I have 2 points, I can draw a straight line. So I draw a straight line through these. I'm not sure how this is going to go. There we go. We're going to do more examples. This was just the first one to kind of get us going. Now, if we look at this and we compare it to what we did last time, here's what we did last time, right? Do you remember the process was just, oh, find the X-intercept. Let me see where did I do it? Here's what we did last time. We had the line, we did the intercept method, we found the X-intercept by setting Y to 0. We found the Y-intercept by setting X to 0. We had those 2 points, we drew the straight line. Pretty clean, right? And that line right there is exactly the same line that we just got here. So I think I would argue, I don't know if you would agree with me or not, that this way, this method seems harder for the problem that we just did, right? Like we had to do a lot more steps this way than we did previously. But like I said, it is useful in certain scenarios. So how about this problem? Let's do a new one. Let's sketch y equals 3/5 x minus 3. Okay, is this a line? That's the first thing you always have to ask yourself. Like, what are you looking at? Is this a linear equation with 2 variables? Do you have x and y? Do you have an equal sign? So yes, right? It's a line. Now, we have 2 methods to choose from, intercept method or slope intercept method. Does anyone have an opinion as to what method to use here? Like
Slope intercept.
Why would you be leaning towards that?
Because the equation is already like starts with y, so you won't have to move anything around.
Yeah, so like right now, just as it sits in front of us, isn't this already in the form y equals mx plus b? Isn't it already like that for us? We have a number in front of x, we have a number by itself, don't we? Like we don't have to do anything if we do the slope intercept method. If we do the intercept method, we have to replace, you know, y with 0 and solve for x. We have to replace x with 0 and solve for y. So there's still a lot of work that we would have to do. But if we do the y-intercept method or slope intercept method, which is what I'm about to do, then I already know that the slope of this line is 3/5. And I know that the y-intercept is -3. Be very careful here. That minus carries with the 3. So our slope is -3. So I can go right now and just start drawing my graph. Okay, I can go straight here, go to my axes. I start off where? Let me call on some people. Y'all seem especially quiet today. How about Victoria? Is Victoria in here? Oh yeah, Victoria is here. I think she might have me muted. I see Victoria, but I'll come back to her. How about Denise? Is Denise here?
Yeah.
Yeah, okay. Are you following okay, Denise?
Yes. Yes.
Okay, good. So if I was going to do this using the slope intercept method, what would I put in first here?
You
where do I go?
put in 305 first.
Okay, so we know that's the slope, right? We know that's slope.
Mhm.
We're going to use that, but I need to have a point that I'm starting at. So
Okay.
what is this number? What does the -3 represent for us?
Y.
The y, right? So why don't we start there? We're going to
Okay.
go to the y-axis, right? And go down or up 3?
Down 3.
Down 3 and then draw a dot, right?
Mhm.
Okay, now from that point, now you can use the slope, Denise. So the slope, what is our rise? Can you tell me what the rise is?
3.
3, and then what's the run?
5.
5. So 3 means 3 up or 3 down?
3 up.
Up, and then 5 means 5 left or 5 right?
Right.
Right, okay. So what you're telling me is from the point that we just started at, from that point, we need to go up 3 into the right 5, correct?
Yes.
Okay, so I'm gonna do that. I'm gonna go up 3, 1, 2, 3, and then to the right 5, 1, 2, 3, 4, 5, and I'm gonna drop a dot right there, and then just draw a straight line, right?
Mhm.
That's it. So if you're given a line in the slope intercept form, like if it already looks like y equals mx plus b, I recommend doing this method because it's super fast, like once you get used to it. Okay, good job, Denise. Let's do another one. I'll call on someone else. Let's sketch y equals, I'm going to throw a little curveball at you here. All right, who am I calling on? What did I just do? Okay, how about Faith? Is Faith around?
Yes.
Okay, Faith. What do you think of this one?
Would we have to turn the 4 into a fraction somehow? Or
Yeah, absolutely. So Faith, you're seeing right now that this looks like y equals mx plus b, right?
yes.
Okay, so m, can you tell me what m is then and tell me what b is?
M is -4 and
Okay.
B is +7.
Okay. Now you said that you wanted to change the -4 into a fraction. That's perfect. I was trying to trick you on that because to use the slope, we have to have rise over run. And so if I just give you -4, it may not look like you have a rise over run, but Faith suggested that we change it to a fraction. Faith, how could we most easily change -4 into a fraction?
Can we put a 1 under the -4?
Yep, just make -4 over 1. Right? You can do that with any number, put it over 1. So we create a fraction, then we have the y-intercept. So I think we're ready to go to the graph. And Faith, I realize you've got some noise in the background. That's fine. You're doing great. Just unmute and then go back. Just tell me what to do from this point, if you could, please.
Wait, what was that?
Just, could you direct me on where to go here?
Oh, so you'll put for the Y the 7?
Okay, so go up 7, 3, 4, 5, 6, 7. Put a dot here. And
Yes.
then from there, where am I going?
Go to the left. Well, you go up 1 and then left 4.
Okay, careful. Remember,
Oh,
this
wait.
is rise and run, right?
Yeah.
Rise and run.
So would you go down?
We're actually going to go down 4, right? And then the 1 on the bottom means we're going to go
1.
right 1. Okay, so -4 on top means we're going to go down 4. So we're going to hop 1, 2, 3, 4, down 4, and then to the right 1. And we're going to go here, and then we're going to draw our line. Like that. Make sense, everyone? Okay, so I'm going to give you 2 problems to work on right now. All right, I'm not going to tell you which method to use. I want you to use whichever method you want. But I'm giving you 2 problems because I think one of them is better to do one way and the other one's better to do the other way. I think it'll be obvious to you, but let's just try it, all right? And I'll give you, I don't know, 6 minutes, 7 minutes. Let's see how far you can get with these. Let's sketch y equals, let's go with 4/3 x plus 1. And then the other problem I want you to do is sketch (4x minus y equals) no, let's not do that, equals 12. Okay, so take, let's see, it's 10:10. Why don't I put my little poll up here, and then you just, when you're done, just click yes, and we'll go when most people are done. Okay, so just do whichever method you want on either one of those, draw the picture, and then let me know when you're done. We're almost there. We've got, I think 17 of you are done out of 20. So I think I'm going to stop here in just about 15 seconds. Okay, so I'm going to go through these real quick. First one, you probably want to use slope-intercept method, right? The method we just talked about. And that's because it's already solved for y. So I know that my slope is 4/3. I know that my y-intercept is 1. So I'm going to draw, I'm going to go fast here. I go up 1, draw a dot. From there, I rise 4, 1, 2, 3, 4. I run 3, so to the right, 1, 2, 3. I draw a dot, and I'm done. See, that's really fast. If you try and do that with the intercept method, it's going to take you a little bit longer. Now, the other one, you could have solved for y. Okay, it wouldn't take a lot to get y by itself there, but you could also do the intercept method. So let's just do a quick little poll. How many of you on the second problem, how many of you did the slope intercept? So how many of you did this method over here on that one? Anyone do that? So yes or no? Okay, so we have a lot of you stuck with the same method. That's fine. You just got to make sure you do it right. And then we had 10 do it with the slope intercept, and we had 6 do it the other way. So let's see. I'll do it both ways, just so we can see. So let me do it with the intercept first. Only 10 of you did it this way. I didn't spell it right. Who cares? Intercept. Okay, so if I do the intercept method, I find the x-intercept first, which means I set y to 0. If I set y to 0, the y goes away. I get 4x equals 12. I divide both sides by 4 and get 3. If I find the y-intercept, I set x to 0, which leaves me with negative y equals 12. I have to divide both sides by negative 1, and I get y equals negative 12. So I go to a graph. I'm going fast here. I go to the right, 3. That's my x-intercept. I go down 12, whatever that is. Put a dot and draw a line. Okay, that would be the intercept method. Now the slope intercept method, we would solve for y. So if I were solving for y here, what I would try and do is first I would move the 4x over. So I'd subtract 4x on both sides. It would go away. I would have negative y equals 12 minus 4x. Now here's a critical step to this problem. You have to get rid of the negative in front of the y. So you have to divide everything by negative 1. So that would leave you with y equals negative 12. And then a negative over a negative would give you plus 4x. And then you rearrange it so that you have y equals mx plus b. And so you have that, 4x minus 12. And so your slope is 4, which is the same as 4 over 1, so rise over run, and then your y-intercept is negative 12. So what you do is you go to your graph. I'm going to just use the same graph here. I go down 12, that's my y-intercept, and then I go up 4, 1, 2, 3, 4, and over 1, and that would give me a dot here, and I would have the same line. Are there any questions on that? Does everyone see how the methods, you know, sometimes it's easier to do it one way than the other? I personally like the intercept method more on the second one because I avoid having to do all this solving for y. But it's up to you. I don't care what you do. All right, we're ready to move on. I want to talk now about the slope of lines, okay? So a little bit about the slope of lines. And I think I'm going to do this slightly different way. So I'm going to go here to Desmos. Okay, what I'm going to do is I'm going to type in here oh, I'm sorry, you can't see this. Sorry. There we go. I'm going to type in here y equals mx plus b. All right. And I'm going to, this computer program allows me to adjust what the m is. So right now, m is 1 and b is 1. So we have a slope of 1 and we have a y-intercept of 1. Does everyone see that? We have a y-intercept of 1 and the slope is up 1 over 1, and that gives us a second point. Is that clear? Now what I'm going to do is I'm going to just use this little slider to change the slope, and I want you to see what happens to the line. I'm going to change the slope to 2 now. Okay? So we have the same y-intercept, 1, but now we have to go up 2 over 1 to get to the next point, right? So I'm going to change it again. Now I'm going to make the slope 3. So what's happening to the line as I make this slope bigger? Bigger.
It's getting closer to the, like it's getting straighter to the y-axis.
Yeah, so let's think of it like a hill, right? It's getting steeper, isn't it? It's getting steeper and steeper and steeper. In fact, I could, let me see, I think I can adjust this, hold on. Okay, let's make it go from slope -100 to 100, and I'll step by 1. And I'll start back here at 1. Okay, here we go. So now that's a slope of 1. Here's slope of 2, 3, 4, 5. Look at, as I get steeper, look at how this number gets bigger. Do you see that it's getting steeper and steeper? But it doesn't like turn and go past vertical. It just gets more straight up and down the bigger the number gets. Even if I change this to 1,000, as I change this, oh, sorry, I went too far. As I change it, as I go out, it just gets steeper and steeper and steeper, tries to become vertical. Now, what happens if I go the negative direction? So what happens if I go, so let's go back to slope of 1, if I can. Here's slope of 1. How about a slope of 0? Ah, look what happens if the slope is 0. We get a horizontal line, don't we? We get a horizontal line. Now, if my slope is a negative number, now my line is, I need to change this. These numbers are too big. Okay, there we go. So if I do negative numbers, notice that the line is pitched down, right? So that's kind of what I wanted to, summarize here with the slope of lines. If m is positive, right? If m is greater than 0, then your line is going to be going this way, like this. If m is less than 0, so a negative number, then the line is going to go this way. If m is 0, then you have a flat line, you have horizontal. Now we have one special case. If your line is vertical, okay, so if you have a vertical line, then m is what we call undefined. is undefined. I want us to just talk a little bit about why a vertical line has a slope that's undefined. Let's just discuss this a little bit. So within this idea here, think about if I had a vertical line and I wanted to get from one point to the other, right? Let's say I wanted to move from one point to the other. So let's say in this case, I want to go from this first point up to this next point. What would my rise be to get there? The rise here would be what? How much did I jump up by?
2.
2, okay. And what would my run be? So what would my movement left and right be?
0.
0, okay. And by definition, slope is rise divided by run. And so that would be 2 divided by 0. And what's wrong with that is we're not allowed to divide by 0, right? Division by 0 is undefined. And that's why we say that the slope of a vertical line is undefined. It's because there's no way to define something where the run is 0. All you need to remember is that vertical lines have undefined slopes. Okay, any questions on this? Positive slope means pitched up, negative slope down, slope of 0 is flat, horizontal line. If your line is vertical, we can't even talk about slope. All right, next idea. Parallel lines. Okay, who wants to volunteer to explain to your classmates as if you were going to explain to somebody, one of your friends, what 2 parallel lines are? Like, can you verbally explain what 2 parallel lines are?
Lines that never cross.
Ones that never cross. Okay, what do y'all think? Parallel lines are 2 lines that don't cross? Do you like that idea? 2 lines that don't cross. Don't cross, don't touch, right? Anybody have another explanation or definition, something else? I would agree with that. That's one way we could look at it. Anyone have anything else? No? I like that definition. Okay, so I want us to take a step back for a second and talk about something that's going to seem completely unrelated to this. Does anyone disagree with that though? Does anyone disagree with the fact that 2 parallel lines should never touch? We're all on board with that? Okay, so I'm going to talk about something that you're going to be like, why are you talking about this? But there's a reason, you'll see. So I had up here, I went up onto Google and I asked Google to show me some cave drawings, some drawings that were done thousands and thousands of years ago by human beings on the inside of caves. And they like to draw animals, horses, and they like to draw pictures of themselves trying to kill those animals for food, right? Got a little arrow here. And these drawings are pretty old. I mean, let's just pick one of these. I'll pick this one. Let's see if we can see how old this is. Of course, it's not going to want to work for me. Okay, I'll pick another one. How about this one? Okay, this one dates back, 12 to 40,000 years ago. Okay. How about this one? Journey to the oldest cave painting in the world. Oh, okay. All right, get on it. See if we can. So this is a 35,000-year-old. That was a 35,000-year-old drawing. Okay, so without being too critical of these people, would you say that their drawings were pretty good? Or would you say that they're more kind of like what you would expect from like a first, second grader? You know what I'm saying? Like, do you think that these are good drawings, or are they more like stickman drawings kind of? What do you think?
They're
No
like
opinion?
stickman drawings.
Yeah, I mean, some of them are decent. Like this one's not too bad. This one's kind of creepy. I don't know what that's all about. Interesting. Yeah, but they are kind of, you know, they didn't really do a great job of convincing us of what a horse looked like. They have a very basic idea, right? The human figures are very stickish looking, right? Everything's very flat. Would you all agree? Everything's very flat. So how is this tied into parallel lines? Here's how. We have this idea in our minds right now that two parallel lines cannot intersect, right? They cannot touch each other. So what I'm gonna do is I'm gonna try and draw something for you right now. I'm gonna see if I can impress you with my drawing, all right? I'm going to draw a road, and I'm going to draw a road with a couple of buildings on the sides. So if I think about a road, I'm gonna have like the edge of the road, and then the other edge of the road. And then I'm gonna have like those little lines that keep us from going out of our lane, right? That are painted onto the road. And then on the side of the road, I have this building. And then over here, I have this building over on this side. And I know it's impressive. I know that you all are impressed by this drawing. That's a road with two buildings on the side. And I would argue that I've followed all the rules. You know, I have all my parallel lines. Look at this line and this line. They're parallel, right? So they don't hit each other. These lines here run parallel to those yellow lines. These edges of the building are parallel. And I would say it's not a bad drawing. Okay, it's not bad because I'm kind of following the rules. Parallel lines don't hit each other. Okay, now what I'm going to do is I'm going to do a second drawing, and I'm going to ask you which one's better. All right. So I'm still going to draw a road, and I'm going to draw two buildings. So here it comes. I'm going to start with the point. Okay. Okay, there's another road. In fact, I think I'm going to put, oops, some trees out here. Okay, there we go. Which one do you think is better? My first one or my second one?
The second one.
The second one looks like more of what a road would look like if you were actually looking at the road, right? Like the only way you're ever going to see a road and two buildings like this is if you're like up in the air looking straight down, right? And then maybe that's what it would look like. But this is more like what your eyeballs would see, right? But what have I done? What have I done with parallel lines? Like in the real world, these lines should be parallel, right? But what's happening to them in my drawing? What are those parallel lines doing? They're touching, aren't they? And then this line should be parallel to the road, but if I were to extend that line actually would go to that point also. Same with this edge. This edge should go, and then this edge right here. Everything that should have been parallel is now all going to this one very magical point right here. And that's what gives us the ability to trick your eye into thinking this is a three-dimensional picture on a flat sheet of paper. Does anyone know what kind of drawing this is called? Or what that point is called? Anyone?
Perspective or
This is called perspective. Exactly. This is called perspective drawing. And that point right there is what's called our vanishing point. If you ever take like an art or drawing class, you'll learn about this. But my whole point is this, that when it comes to math, we have an idea of what two parallel lines are. And I forget who responded, but the definition that was kind of thrown out there, where is it? I've lost it. Oh, here we go. Two lines that don't cross, don't touch. I think Abby responded with that. This is good. I like that. It works in math. But if you want to do any drawing, if you ever want to do any drawing that looks real, you have to throw the math rules out the door. And you have a new set of math, like it's an entirely different world of math called perspective math, or in this case, it's actually called a form of non-Euclidean geometry. That's not important. But I want you to understand that the world we live in, the math, the structure that you learn in school and what you're learning right now is all a certain type of math. But there's a bunch of different maths that we have for different things. And one of them is for drawings. And so once humans evolved and our brains were able to understand what it was necessary to trick our eyes, then we came up with this new sort of technique. And so now if I go to Google and I do like perspective drawing, all right, let's do perspective drawing. And I look at some images here. You'll notice that all of these pictures are oh, this one's a good one right here. See, this is a good representation of what that would look like if you were actually standing here on these railroad tracks. Now, in the real world, we know that these two tracks are parallel, like they're never going to intersect. But in the drawing, they do. They intersect at the vanishing point. And so it was an evolution of the human thinking and math that allowed us to get better at drawing things. So when you're playing a video game, right, and you're running through this, whatever you're doing, right, and you've got all these buildings and whatever scenery going by you, all of that's being done in perspective so that it looks like what you would see. If we were still, you know, if we hadn't developed our brains and developed the math, then we would still be here. Like we would still be back here trying to draw things flat, which would never represent what we actually see. Okay, that was a slight little detour. What time? Oh my gosh, it's already 10:40. Okay, parallel lines. Let me finish up with, we'll at least talk, I'll at least define what parallel lines are. So parallel lines I agree with you that they don't intersect, but here's the way we're going to look at it. Parallel lines are two lines that have the same, what do you think two parallel lines have in common?
Slope.
Slope. Any two lines that have the same slope are parallel. So I'll give you a quick example underneath this. Take a look at this line. Okay, let's call that L1. L1, I'll do capital L1. L1 is that line. L2 is this line. Are they parallel? What's the slope of the first line? 4, right? What's the slope of the second line? 4. They have the same slope. They are parallel. That's the easiest, quickest way to check to see if two lines are parallel. You just compare their slopes. That's all you have to do. Okay. What about perpendicular? We heard that before. Two lines are perpendicular. If you were to try and explain that to somebody, what perpendicular means, It's not as easy as parallel. That's two lines that hit at a perfect cross, right? It would be like parallel lines look like this, right? They have the same slope. Perpendicular, one line does one thing and the other one comes in and hits it at a perfect, what we call 90-degree angle. That's a perfect little square right there. Okay, that's perpendicular. What do you think the relationship between the slopes are there? If parallel, they have to be the same slope. What do you think it is about the slopes of perpendicular? What do you think the relationship is? They're obviously not the same, right? Because then they'd be parallel.
They
So what
have
do
to
you
be
think?
opposite.
Opposite, that seems reasonable. So like if one of them is 4, the other one's -4 maybe, right?
Yeah.
Okay, it's that, but not quite. It's not only the opposite, but it also has to be what we call the reciprocal. So two lines with opposite and reciprocal slopes. Now I'll explain what opposite and reciprocal means. I'm going to give you an example. So let's say we have L1, we have a line, and let's say that the slope of that line is 4x minus 1. Okay, so the slope here is 4. For the other line to be perpendicular, we have to take this 4. We have to take the opposite of it, which is -4. Okay, so that's the opposite. But then we have to take the reciprocal of it. Reciprocal means flip the fraction over. So first we have to write it as a fraction, -4/1. And now we do the reciprocal. I'm just going to put recip. The reciprocal is 1/-4. That makes sense? Change the sign, make the opposite. So 4 went to -4, and then take that as a fraction and flip it over. And that is what the slope of this line would have to be. This would have to be -1/4x. And then this part could be anything, +3 or whatever you want. But that slope right there is the negative or opposite reciprocal of the original one. Now I'm out of time. We'll pick up with this next time. In terms of homework, I would encourage you to finish up the homework for intercept method if you haven't. And then as far as the slope intercept method, let me look at the homework real quick. You should be able to do these sketches. And then just go up through number 14. We'll talk about 15 through 20 next time. This talks about parallel and perpendicular and stuff. So just do up through number 14 on the homework. Do your best. And I'm even going to tell you that on your homework, if it tells you to do it in slope intercept, like do the slope intercept form or method, if you want to do the other method, you can do the other method. All I want you to do is be able to graph these lines. So you pick. All right, that's it. Everybody have a great weekend. I will see you on Tuesday. When do we have our next test? I feel like it's right around the corner. It says it's October 6th. So that's it's a week from Tuesday. So let's just see where we are, okay? Let's see where we are. We're gonna keep that date for now, for exam 2. But we'll talk next week. All right, have a great weekend, everyone.
All right, thank you, sir.
Thank
Bye,
you
sir. Have a
again
good
for
day.
your attention and time.